Radiation exposure could be the most important issue that needs to be solved or prevented against if we're going to be traveling further and further into space. One of our biggest concerns for astronaut health in space is radiation exposure.
Showstopper.
We have to be careful about that here on Earth as well. When we're out in the sun, we want to wear a sunscreen. Protect us from the harmful effects of the sun. In space, we don't have an atmosphere or a magnetic field, which also protects us from radiation here on Earth.
This is how they use misinformation and misdirection to keep the public ill-informed. This is how everyone is confused and why everyone is confused. Because this right here is an astronaut doing everything he can to misinform you of space. Now, he just stated, in space, there's no magnetosphere to save us. There's no atmosphere to save us. We don't have any of that. And that radiation is a threat. And he's absolutely right. And all of my videos show exactly why that is. However, he's disregarding one simple fact. He's talking about the International Space Station, which is in Earth's magnetic field, which is behind the bow shock of the magnetosphere, deep within the magnetosheath and the plasmasphere and all of the magnetospheric bands, safely confining all of the atmospheric layers. So the International Space Station is not only within Earth's magnetosphere, but it's safely within Earth's atmosphere. Now, Earth's atmosphere, it extends to 6,213 miles out. They're 230 miles out. They're very, very, very safely within Earth's atmosphere. We're just not in the troposphere. So when you go on a plane and you get in the stratosphere and you're leaving Earth's atmosphere, you're still correct. You've left Earth's atmosphere, but you went from the troposphere to the stratosphere. You just left a level of atmosphere. You're still within Earth's atmosphere. So if you were to go from the stratosphere to the mesosphere, go from a plane to a rocket plane, and now you're actually in space. Well, now you're in space, but not the space he's talking about, because he's talking about deep space. That's space. Now, if you were to go above the mesosphere to the thermosphere, now that's outer space, and that's where the militaries are. That's where all the world's nations have stopped. The very, very, very beginning of outer space. Now, humans have never been to deep space. That's 25,000 miles out. We've never been able to put anything out there. We're hoping that the Parker probe will touch the plasmasphere, which is close to 7,000 miles out. And once we figure out exactly what those raw particles within the magnetosphere, when we actually leave Earth's atmosphere, outside of the exosphere, which is above the thermosphere, once we've left all of those areas and we understand what that mass and that energy is, then eventually we'll be able to figure out ways to get into it and navigate it, or most likely communicate in it first, which is why 5G gamma communications just started, because that is the type of energy and the mass that you're dealing with when you're in the exosphere, trying to push into the plasmasphere. So, this is misdirection. He specifically stated all of that because, well, if you think now that the International Space Station is in space, you'll think that he just talked about it being outside of Earth's atmosphere, outside of Earth's magnetic fields. That's misinformation, that's misdirection. It's NASA stating radiation is the problem, radiation is why we can't. All of the prestigious universities and all of the major particle scientists, physicists and solar physicists, all the scientists in the world have concluded why radiation and the levels of, as you go up the levels of atmosphere into the magnetosphere, why we can't and why we don't. This information is why they continuously pump it out so that you get confused, misinterpret space and the levels of space, and then just combat any information someone will present when they state things like, we can't go to deep space. And you say, yes we can, I just watched this astronaut talk about why we go into space, and how space is outside of Earth's atmosphere, and outside of Earth's magnetic fields. He just said so, so it's gotta be true. When that was misinformation, because no, it's in the thermosphere, safely, thousands and thousands of miles within Earth's atmosphere, just above this layer of atmosphere.
If you're above that, you're going to be exposed, and that we're very concerned with, so we try to do whatever we...
Because the International Space Station isn't above that, they don't need to worry about it. However, passive shielding, like Marco Durante from GSI and all prestigious universities have stated, can only work within the lower levels of Earth's atmosphere, 230 miles up. You remember, it goes to 6,213 miles up. So with all of that extra atmosphere, the density of, say, Mars, still above your head, the density of Mars' atmosphere, excuse me, above your head, then you have all of that filtering the solar particles. Just like they're more exposed than we are on Earth, it gets greater and greater. All of my lectures in all of Princeton, UCLA, and Berkeley, and GSI, and CERN, and LIGO, every single company on Earth has shown results as to why various levels of radiation exist, how they work with them, and how they're confined by them.
Can to shield the astronauts from radiation, and we do that in the spacecraft, for example, by using certain materials and shielding that'll protect them from radiation.
Now remember, Marco Durante and all the prestigious universities from Berkeley, and if you look at NASA Goddard's NASA channel, or you go on to nasa.com and you look at the Goddard section for heliophysics, you'll find that the last 10 studies have had Berkeley and Princeton and everybody confirming that we need active shielding, a magnetosphere like the Earth, on our crafts if we want to leave the magnetosphere like our Earth's. GSI has shown that the particles that they're talking about are only confined to deep space, and that the filtration system of Earth's magnetic fields, the electromagnetic reconnective points, and all of the anomalies that we're just learning about are why we only get 1% that comes through the bow shock. And then the people on the International Space Station using this shielding are only getting 1% of that 1%. So that's why Marco Durante shows, and Princeton and Berkeley and everyone on NASA Goddard's heliophysics channel is now confirming that within Earth's active shielding, within the magnetosphere, deep within all of the thermal and exo layers of the Earth's atmosphere, in that field we can use passive polymer transitional metals, all of these different compounds, to shield ourselves from the 1% of the 1% of that radiation we're exposed to. However, if you want to go further up, passive and transitional metals, like he's talking about here, do not work. Then you have to use active shielding, electromagnetic forces, again, things that NASA has stated very clearly we need. So,
it does monitor that. We have a device called the dosimeter, which is more or less looks like a piece of plastic that can measure the amount of radiation you have taken, and it's placed in your launch suit, and then you hand that in at the end of the mission and they read it to see how much radiation you've been exposed to.
So NASA ended up showing it's about 200,000 millisieverts of radiation exposure a year. When they're on a spacewalk. Now when they're inside the International Space Station, that's actually decreased by half, which makes it possible for us to inhabit space in the International Space Station with that passive and transitional material, the polymers. However, when we go outside, we're at a much greater risk. It literally doubles our risk just stepping outside of the International Space Station at 230 miles up, when we still have atmosphere that goes to 6,213 miles up above us. So even though we're confined and consolidated by all of that atmosphere, we still are exposed to twice as much radiation outside of the International Space Station than we are inside. So if they want to put an International Space Station any higher up, or if they want to go any higher up, they're going into radiation levels that GSI has shown are 3 times that. So instead of it being 200,000 millisieverts they're exposed to, being at 230 miles up, they go 1,000 miles up, they're starting to get into actual space, where space is 700,000 millisieverts. Now, that of course is not like Mars' atmospheric layer, it's not going to be like the lower thermosphere. And so when you're inside the International Space Station, you're going to be exposed to at least 1.5 times what you would be exposed to if you were outside at 230 miles up. So mathematics prove right there that the reason we're not in the mid or upper thermosphere is it's 3 times the radiation exposure, and that passive and transitional metals, the polymers that he's talking about, cannot work at that higher level, only within the 230-mile point.
Further and further away, we get further from Earth, radiation exposure could be the most important issue that needs to be solved or prevented against if we're going to be
Showstopper.
traveling further and further into space.
Everyone
Something we don't always
says it.
think about. Radiation exposure can be very harmful, and it's a real challenge for space travel.
The end.